Hello, today I'm going to show you version 1 of my coil gun. Here it is. As you can see, it's a mess of extended wires and open circuits, which is not good, but it does work, and I'll show you a demonstration of that in a second. Like I said, nothing crazy impressive, can't even aim at the target properly, but it does work. So let's talk about how. So this is a mess that I call the first iteration of my coil gun. As you can see, there's two coils, and then these boards are pretty much exactly the same. There's two 50-volt capacitors in parallel to give that will drain power into the coil to actually generate the magnetic field that pulls the projectile. And then there's this button which triggers the first coil to fire, and then this Hall effect sensor which is meant to detect the magnetic field in the projectile as it travels through the first coil and then trigger the second coil. There's some problems with that I'll get into in the future. There's also the MOSFET and the MOSFET gate driver to actually open the circuit or to close the circuit between the coil and ground so it actually fires. And then my mess of a power bank, which this is where the power comes in these two middle leads, and then it will flow either to the outside terminal to charge the capacitors or the inside terminal to power the circuit. And yeah, I'll show you the circuit schematic in a little bit. This is a circuit schematic for the board that operates the coil gun. There's this, which is the 3-terminal screw gate that connects to power and ground. And then you can see that the capacitors get 35 volts from the first pin, and then they also connect to ground through here. And then the capacitors also connect to the positive end of the coil, which is connected across this other screw terminal. And then this part down here is for the MOSFET and the gate driver. So there is a little 3-pin header which connects to 12 volts coming from the power supply, and then to ground, and also to the signal which comes from either the button or the sensor. And then it powers this NPN transistor, which basically inverts the signal from the button and then feeds that into the gate driver or to the gate of the MOSFET, which opens it, connects the circuit, and then allows the coil to fire. The coils themselves are hand turned. I 3D printed this little base that is 15 millimeters across and has a hole in the middle for about 4 millimeter diameter that fits the barrel, and then the 3 millimeter projectile that goes through the barrel. In a single layer of the coil, there is about 15 turns of 22 gauge magnet wire, and then there are about 5 layers of coil. So if you ask me why I made any of these design decisions, it was pretty arbitrary. The only thing I tried to do is keep the gap between the first layer of coil and the projectile in the middle as small as possible for the strongest magnetic field strength. That's my coil gun as it stands today. As you can probably tell, is a lot of improvements I need to be making for the second version. The first of which is going to be adding an enclosure, so I'm not holding it and trying to fire like this. The second is going to be using a larger projectile, because more massive projectile means more kinetic energy, which means more force when I'm shooting things, which would be cool. The next thing I want to do is probably try to optimize the coil design. So fine-tuning the number of turns in the coil, the length of the coil, how many layers, and all of that. And then also the stage timing. Right now I'm using this Hall effect sensor, which is not a good choice because it's supposed to detect the magnetic field in the projectile as it's moving across it. But right now what it's doing is just detecting the magnetic field in the coil as soon as it's turned on. And that means that the second stage is firing too early. And so I'm probably going to be using infrared LEDs so I can detect when the coil breaks the beam and actually time my stages a little bit better. And yeah, I mean, there's a couple other efficiencies I can make, obviously, like putting the capacitors in the same place and like routing my wires a lot better. But yeah, stay tuned for that because I'll make a new video in probably in a couple weeks.